Hello, good evening all.
Good evening, sir.
Good evening. Hello, I am Saurabh and I welcome all of you to this live session for the NPTEL course IC Engines and Gas Turbines. So I think we can begin. So this is a 12-week course, right? So in each week there will be uploaded some lectures, and after those lectures, in each week you will get some assignments, and the purpose
Yes, sir.
is to solve your doubts if you have any doubt in those assignments. So in today's session, we will be focusing mainly on the content of week 1 and
Yes, sir.
assignment 1. Okay. So if you have any doubt, then I encourage you to please uh, ask by unmuting yourself, or you can type in the chat box. Okay. Okay. So the course name is IC Engines and Gas Turbines, right?
Yes, sir.
So IC, that is internal combustion, right? Internal combustion engines. So as the name suggests, those type of engines where the combustion is taking place inside your engine. Okay. So if you check some old books for the IC engines, then in many books you will find that gas turbines are also included in the IC engines. Why? Because inside the gas turbines, the combustion takes place inside the engine, right? So when we see IC engine or internal combustion engine, then it means that combustion is taking place inside the engine chamber, combustion chamber. So technically, if you see that IC engine includes both reciprocating engines as well as gas turbine engines. But in this course, when we say IC engine, then basically we are
Reciprocating.
yes, reciprocating engines. But technically, if you see that this should also include gas turbines, right? So in this course we will be discussing gas turbine as a separate unit, but technically they are the internal combustion engines. Okay. So reciprocating. So IC engines for this course means reciprocating engines, and reciprocating engines in reciprocating engines we will be discussing mainly petrol engines and diesel engines, right? So diesel engines are compression
Yeah.
ignition engines and petrol engines are SI engines, right? So this basic idea you already have from the content of week 1, right? So we will try to solve some problems. Okay. So you will get how to solve, you will get an idea how to solve the assignment problems. Okay. So in the week 1, the content was very introductory level. So there was not any complex problems, right? So for example, what component is absent in a compression ignition engine? So you know how a compression ignition engine work. So if you know how this compression ignition engine work, then you can easily answer this question. Okay, so options are fuel nozzle, spark plug, carburetor, or piston rings.
Sir, spark plug
So
or carburetor.
okay, spark plug and carburetor. So let us see how this compression ignition engine work. So in this compression ignition engine, you know that only air comes in the intake stroke, and that air is compressed. And after compression, this air becomes very hot. And in that hot air, if you spray some fuel, that is diesel fuel, obviously, then because the temperature is already very high, that will burn, right? The fuel will burn. So after burning, after combustion, the pressure inside this chamber will become very high and it will push the piston down, right? So this is how you get the power in a compression ignition engine. So what you should have, you should have a fuel injector, right? Because you are injecting the fuel in the hot air. Okay. So the fuel
Okay.
nozzle or the fuel nozzle or injector will be there, right? So it is there in the compression ignition engine. The spark plug engine, do you need any spark plug? We don't need any spark plug because air is already very hot, and the temperature is more than the auto ignition temperature of diesel. So what is the auto ignition temperature? That probably we'll learn in the upcoming lectures. But it is very
It is
hot
very
and
hot
the
and
fuel
the fuel
auto
auto
ignites
ignites,
when then we say
then we
that
say
it
that
is
it is
sorry, someone. Okay, so for diesel engine, the auto ignition is there, so we don't need any external source or spark plug. So spark plug is not there, right? Carburetor. So what is the purpose of carburetor?
तो कार्बोरेटर एयर फ्यूल को मिक्स करके उसमें भेजता है इंजन सिलेंडर में अंदर.
Right. So the purpose of carburetor is to prepare a homogeneous mixture of air and fuel, right? But in diesel engine, you don't need a homogeneous mixture of air and air
Yes, sir.
fuel, right? You are getting only
Yes.
air, and in the hot air you are directly injecting the diesel. Okay, so in diesel engine, carburetor is missing. Okay, so instead of carburetor, how the fuel is being injected? By using the injector or the fuel nozzle. Okay, the piston rings are there. Okay, in all types of engine, piston rings will be there. So the correct option will be spark plug and carburetor, right?
Yes.
So I think we can move to the next question. So if any doubt, then you can please ask or you can type in the comments. Okay. Question number 2. It says which thermodynamic cycle is associated with SI engine or spark plug engine?
Also,
Okay. So you know what is a thermodynamic cycle? Sorry. A thermodynamic cycle is an just give me 1 second. Okay. So you know that in diesel engine or petrol engine or in any type of engine, you are burning some mixture of fuel and air. Okay, and that mixture of air and fuel is obviously not a ideal gas. Okay, and the pressure and temperature and volume, they are continuously changing. So whatever thermodynamic cycles you have studied, whether it is Carnot cycle or Otto cycle or diesel cycle, they are very ideal cycle and they are not used in in the real applications. But since temperature, pressure, and volume, all these thermodynamic parameters are continuously changing in your engines, so the analysis becomes very difficult. Okay, so what we do, we assume some ideal cycles, some air standard cycles, so that we can compare what we are getting from air standard cycle and what we are getting in the actual case. Okay, so when you take the ideal conditions, in the ideal conditions you get the maximum efficiency. Okay, and the actual case there are a lot of losses and you get less efficiency. Okay, so for making your calculations easy, just to get an rough estimate and just for comparison, you use some air standard cycles or thermodynamic cycles. In those thermodynamic cycles there are a lot of assumptions. For example, your working fluid is an ideal gas, and the properties of ideal gas are constant at all these temperatures and pressures. Okay, so there are different thermodynamic cycles for different type of engines. So here it is asked that which type of thermodynamic cycle is used for SI engine, and someone has already pointed out the correct option, that it is the Otto cycle. Diesel cycle is for diesel engine or CI engine, or Otto cycle is for SI engine. So how this Otto cycle looks like on a PV diagram? First of all, there will be an isentropic compression, right? Then there will be a constant volume heat addition process, then there will be isentropic expansion or the power stroke, and then there will be exhaust, right? Constant volume exhaust. Okay, so this is point 1 to 2. So this is isentropic compression, and 2 to 3 it is heat addition, and 3 to 4 it is power stroke or expansion, isentropic expansion, and 4 to 1 is your exhaust stroke. Okay, so this is Otto cycle. Okay, the Rankine cycle is for steam engines. Breton cycle is for gas turbines, right? So Breton cycle you will study later uh, when you study the gas turbines. Okay, so we'll move to the question number 3. It is saying that which statement is true about two stroke engines. So I think you have already studied the difference between 4-stroke engines and 2-stroke engines, and the difference, I hope it is clear, right? So if any one of you have any doubt regarding the difference between 4-stroke engines and 2-stroke engine, then I can just briefly explain. In 4-stroke engines, what you have 4 strokes to complete one thermodynamic cycle. So first stroke is the intake stroke. Okay, so the piston comes down from TDC to BDC. Okay, the TDC is stopped at the center, and so piston is coming down from TDC to BDC. So since piston is coming down, so it will create some sort of vacuum or low pressure inside the chamber. Since the pressure is lower inside the chamber, so air will come inside. So this is intake stroke. Okay, so this is intake stroke. Now piston has come to BDC. Okay, so now piston will go upward from BDC to TDC. So this valve, the intake valve will be closed and air will be compressed. So second one is your compression stroke. Okay, then the fuel is injected in the hot air, and after combustion the piston is pushed down and you get power stroke. Okay, and during the power stroke all of the fuel air mixture will have been combusted, and you have the uh, residual gases, right? So those gases need to be removed. Okay, so in fourth stroke or the last stroke you have the exhaust, right? So these are the 4-stroke in the uh, 4-stroke engine. But in 2-stroke engine the thermodynamic cycle completed in 2-stroke only. Okay, so it looks like something like this. You have this cylinder, and this is your piston. Okay, and please remember one thing, that in 4-stroke engine you have intake valve and exhaust valve, but in 2-stroke engine you have only ports. Okay, you don't have these type of valves. What are the valves? Uh, Valves are like this. Okay, so for opening these ports, opening and closing. Okay, so in 4-stroke engine you have valves, but in 2-stroke engines you only have the valves. Okay, so there will be one valve here, exhaust valve, sorry, exhaust port, and there will be one more port, that is intake port, and there is crankcase. Okay, and there was one more important port, that is called transfer port. So my drawing is not very good, but if I try to show some good diagram, then probably you will appreciate it better. Okay, so here it is a better picture. Sorry. So this is two-stroke engine. Okay, so can you see here? This is your exhaust port. Okay, this is your intake port. Okay, so I will show you one by one. So I think the hardware is clear. Okay, what are the components? That is clear, right? So exhaust port, can you see the intake fuel, the intake port that will from intake port you will get fuel air mixture, and there is one transfer port. Can you see where is the transfer port? So this is the transfer port. Okay, so transfer port is basically used to transfer the fuel air mixture between the cylinder and this crankcase. Okay, now what will happen? Piston is going upward. Okay, the piston is going upward to a TDC. So now you can see that transfer port that is being covered. Okay, so that is being covered here. Okay, which I think this color I can use. Here you can see that this transfer port is covered, right? Can you see here it is covered, right? Covered by what? Covered by piston. Okay, so it is closed, right? And exhaust port is also covered by this piston, so this is also closed, right? So the only port that is opened, this is inlet port. Okay, so since the piston is going upward toward TDC, the air will come inside, come from this inlet port in the crankcase. Okay, so when the piston will reach TDC, some air fuel mixture would have been come inside this crankcase. Okay, so now what will happen in the next step, that we will see in the next page. Okay, so now since the piston has already moved up to the TDC, so whatever content was there here in this cylinder, that would have been compressed. Okay, fuel air mixture would have been compressed, and spark plug action will take place. Okay, so spark plug, after spark plug action, there will be combustion, and because of combustion you will get high pressure, and this piston will be pushed down. Okay, so here you can see that combustion has taken place, and a lot of pressure has been generated in this chamber here. Okay, is it visible when where I'm writing? Okay, so here you have got high pressure, and because of this high pressure, the piston will be pushed down. Okay, now what will happen? The piston, as it comes down, it is coming down. Okay, it is coming, still coming down. It is still coming down. Now you can see it is coming down, and this exhaust port is being uncovered, which was initially covered by this piston. Now it is started to become uncovered, right? So now it is become uncovered. So whatever content is there in the cylinder, this will start to come out. Okay. So whatever gases are there inside the cylinder, they will start to come out from the exhaust port. Okay. There is no valve, only piston is covering and uncovering these ports. Okay, so whatever gases were there, they will start to come out from the exhaust port. The piston is still going down. Okay, piston is still going down, it is still going down. Now it has come down more, and the exhaust port has completely opened, so whatever gases are there, they are still coming out. Okay, now still the transfer port is closed. Can you observe that transfer port is still closed? Okay, now when the piston will come down further, what will happen? It will come down further. What will happen? Now transfer port is also being opened. Okay, it has started to open. So what will happen? Whatever content was there in this crankcase, so what was there in the crankcase? Air fuel mixture, right? In the crankcase there was air fuel mixture. Now since the piston is coming down, so it is and intake port is closed and piston is coming down, so it is compressing this content of uh, content in the this space. Okay, so whatever there is in crankcase, that is basically air fuel mixture, that is being compressed. So because of pressure difference, so more higher pressure is being created there. So because of higher pressure, it will be it will start going to the cylinder, right? Cylinder chamber from through the transfer port, right? Still piston is coming down. Okay, so it will come down further. So what will happen? Now you can see it is still coming down and more content is being transferred from the crankcase to the cylinder chamber. And please note that exhaust is still taking place. Okay, so these burnt gases are coming out from the cylinder chamber, and the air fuel mixture is being transferred from the crankcase to the cylinder chamber. Okay, so these two processes are taking place simultaneously now. Okay, these two processes, the exhaust process and this transfer process, is being simultaneously taking place. Okay, now the piston will still come down further. Okay, so more gases, more content from the crankcase will come into the chamber. Okay, okay, still coming down, still coming down. Okay, so it has come down to it is for now it is just starting going upward. Okay, it has going it has started going upward. So what will happen? This inlet port will open and fuel air mixture will start coming out to the crankcase. Okay, here. Now it will move upwards further. Now you see, now you see it has reached here near the transfer port. Okay, so if it moves further upward, then it will close the transfer port and the transfer process will be stopped. Okay, so let us see. Now it is coming upward towards TDC and this transfer port has been started to be closed. Okay, now the transfer port has been closed. Okay, so transfer port has been closed, but more and more air fuel mixture is coming inside this crankcase. Why? Because piston is moving upward and some sort of less pressure is being created in the here in the crankcase. Okay, so air fuel mixture is coming inside, but exhaust port is still open. Okay, exhaust port is still open. When the piston will move upward, then it will cover the exhaust port. Okay, so now it is moving upward and exhaust port is now being closed. Okay, being covered. Now it is completely covered. Okay, piston is still moving upward, then it will, so what it's doing now, it is compressing the air fuel mixture, right? Now it is compressing the air fuel mixture. It is going towards TDC. It is compressing. More compression, more compression, and when it has reached the TDC, then what will happen? A spark plug will ignite this air fuel mixture. Okay, so there are only two strokes, one from TDC to BDC, from top dead center to the bottom dead center, and from another stroke is from bottom dead center to the top dead center. And within these two strokes, the whole process is completed, right? The inlet process, the exhaust process, the combustion process, the power stroke, all the steps are completed within these two strokes. Okay, is that clear? I hope this is clear, and we can, if there is any doubt, then please ask. Okay, now one more thing. What is happening in the crankcase? In the crankcase, there is a crankshaft. Okay, so there is a crankshaft. Okay, so this is, let us say it is crankshaft. It is rotating. Okay, and this is connected the piston. Okay, so as this crankshaft rotates, so what will happen? This piston will move up and down. Okay, so when this crankshaft will complete revolution one revolution, then piston will complete two strokes. Okay, I will make it more clear. When the piston is near BDC, the shaft will be somewhere here. Okay, correct. And when piston is near TDC, this will be like at the upper portion. Okay, so ये ऊपर नीचे हो रहा है. Okay, so the piston is reciprocating. So when this shaft completes one rotation, the piston has completed two strokes. Okay, right? So two strokes of piston, they are equivalent to one revolution of crankshaft. Okay, and in four stroke engines you need four stroke four strokes for one thermodynamic cycle, right? Thermodynamic cycle. And since two strokes are equivalent to one revolution or crankshaft, so two strokes, okay, so four strokes will require how many revolutions? Two revolutions, right? Two revolutions of crankshaft. Okay, right? So in four stroke engine, the one thermodynamic cycle will be completed in two revolutions of the crankshaft. While in four stroke engines, in two stroke engines, one thermodynamic cycle is completed in two strokes, and two strokes are equivalent to one revolution of crankshaft. Correct? So this is very basic and very important. Okay, so these concepts should be clear. Uh, then only you will be able to solve the numerical problems. So that's why I am giving a lot of stress here. So is that clear? Okay, so I hope this is clear. I will repeat that in four stroke engines, uh, I will repeat that for two strokes of piston, you need one revolution of crankshaft. In four stroke engine, you will need two revolution of crankshaft because there should be four stroke for completing one thermodynamic cycle. In two stroke engine, two stroke will complete one thermodynamic cycle and two strokes will correspond to one revolution of crankshaft. Okay, now you can easily answer this question. Which statement is true about two stroke engines? So we have discussed two stroke engines and how and also we have discussed about the crankshaft rotation. Okay, so first option is saying that they complete one cycle in two revolution of crankshaft. So is this true or false? Can anyone please answer?
False.
Yes, it is false. Why? Because for two strokes, you need one revolution. Okay. In two stroke engine, there are only two stroke for completing one thermodynamic cycle, and two stroke corresponds to one revolution of crankshaft. Okay. Question B. They are heavier than four stroke engines?
No.
No, they are lighter than four stroke engines. Okay. Part C says they complete one cycle in one revolution of crankshaft. So is this correct or false?
True है, true है.
Yes, because in one revolution of crankshaft, there will be two strokes, and two stroke engine complete one thermodynamic cycle in two strokes, right? Part D is saying they are commonly used in modern automobiles.
No,
No, because
because
in
they create
modern,
pollution.
yes. Why? Because combustion is not very good. You have already seen that a lot of processes were taking simultaneously. Even before the exhaust process is completed, intake process has already started. Okay, so one process is not completed and you are starting another process, so there is overlap. Okay, so the processes are not completed. Okay, so they provide less efficiency means you are putting more fuel and you are getting less power, so more pollution. So in modern automobiles, whether it is your motorcycle or your car or your any type of reciprocating engine, most of them are four stroke engines. So these two stroke engines were used in like older scooters, right? So some old scooters, they were running on two stroke engines, but nowadays most of the engines of your motorcycles or your cars, they are four stroke engines. Okay, but two stroke engines are again they are supposed to come into the picture For example, why they? Because they are lighter than four-stroke engines. So there are certain applications where you need lighter engine, you need less weight. For example, if you want to design some drone, okay, in drone you need very light weight engine, okay, you cannot put heavy weight on your drone, okay. So in those type of applications, these two-stroke engines are again expected to make a important role. But anyways, I hope that now you can answer this question. We have already answered actually, okay. So which statement is true? They complete one cycle in two revolution of two revolution of crankshaft. This is not correct. They are heavier than four-stroke engine. No, this is not correct. They complete one cycle in one revolution of the crankshaft. This is correct. They are commonly used in modern automobile. This is not correct, okay. So I hope that two-stroke engine, four-stroke engine, the crankshaft revolutions, these concepts are clear, right? So if there is no doubt, then we should move to the next question. Okay. Question number 5. It says the compression ratio CR of a CI engine, compression ignition engine, typically ranges between. Option A says 5 to 10, 10.5. Part B says 12 to 20. Part C says 20 to 25. Part D says 1 to 5. This is very easy question. You can easily answer. So anyone please answer, then we will move to the next question. Okay. The compression ratio of CI engine is more or SI engine is more? Which is higher? Which type
कंप्रेशन
of
रेशियो
compressor? You know compression ratio?
सीआई इंजन का सर ज्यादा होगा.
But I think all of you know the compression ratio. If you don't know, then I will quickly explain what the compression ratio is. As we already discussed that piston is moving upward and downward, and there is certain limit after which it cannot go up further, okay. There is some limit, it cannot go further. Why this is limit? Why there is some limit? Because there are a lot of physical constants, some geometrical constant as well. And for example, in compression ignition engines, you need to put one injector, right? There are some valves, okay. Valves need to move up and down, right? So some space should be there. You cannot move, you cannot make this volume zero, right? So there will be some gap, okay. So this is the highest limit. You cannot go up more than this, okay. So this is called top dead center, TDC. So when you have reached the top dead center, there is some volume left. This volume is called clearance volume, okay. This volume is called clearance volume. And when piston is at its minimum position at the bottom, okay, here, now it cannot go down further. It cannot go down further, okay. So this is another limit, okay. This is another limit. So this is called bottom dead center, okay. So when the piston is at bottom dead center, the volume inside the cylinder is maximum, right? So this whole so this is the volume, the whole volume when the piston is at BDC, okay. So this is called volume at BDC, volume at BDC. So this is the maximum volume, okay. And when the piston is at TDC, this is called clearance volume, okay. This is called clearance volume or volume at TDC. This is the minimum volume. This is the minimum volume, okay. And the volume between this area when where this piston is moving up and down, so whatever volume is being swept, this is called swept volume, okay. So this volume is called swept volume, okay. Swept volume. So swept volume will be equal to volume at BDC minus volume at TDC, okay. So this is your swept volume. And the ratio of maximum volume to the minimum volume is called compression ratio. Okay, compression ratio is the maximum volume to the minimum volume. So when we will get the maximum volume when piston is at BDC, bottom dead center, and when we will get the minimum volume when piston is at top dead center. Okay, so this ratio is called clearance volume. Okay, so in which type of engine you will require more compression ratio? In diesel engines you require more compression ratio. Okay, why? Because you need sufficient temperature which can auto ignite the diesel fuel. Okay, if you are using less compression ratio, then temperature may not reach up to that level which can auto ignite the diesel fuel. Okay, and one more thing, that efficiency is also dependent on compression ratio. More compression ratio provides you more efficiency. So usually diesel engines or the CI engines are more efficient than the SI engine. So most of the heavy duty machinery, for example, your tractors, your JCB or these type of bulldozer, these type of heavy duty machinery, most of them are using CI engine, right? So compression ratio of CI engine is typically in what range? So 5 to 10.5 or 12 to 20 or 20 to 25. The correct option here is 12 to 20. Okay, so these compression ratio of a CI engine can be like 15 or 17 or 18, so something in that range. Okay, and compression ratio of SI engine or spark ignition engines are usually less than these compression ratio of CI engine. Okay, so compression ratio of SI engine is usually in this range 5 to 10.5, and for diesel engine it is in this range 12 to 20. Okay,
सब पेट्रोल के लिए 5 to 10 रहेगा.
हाँ उसके लिए कम रहेगा, पेट्रोल वाले के लिए कम रहेगा. क्यों कम रहेगा? क्योंकि यू आर यूजिंग स्पार्क प्लग. ओके, so these are the ranges. Okay, okay, if there is any doubt, then question number 4, then please. If there is no doubt, then we will move to the next question. Question number 5, it says that you are designing an engine for an unmanned aerial vehicle or UAV. Sometimes these are called drones, right? So which type of engine you will prefer? A CI engine or SI engine? Compression ignition engine or spark ignition engine? Which type of engine you will prefer?
Spark ignition.
Spark ignition engine. Why? That already we have discussed in some previous question that in UAV applications or in drone applications, your main focus is on the weight. Okay, you don't care about the fuel economy. You do, of course, but there your main focus is the weight. Okay, you don't want to put more weight on the this air vehicles. Okay, so which type of engines are heavier, CI engine or SI engine? Compression
CI
ignition,
engine.
CI engines, right? Weight of CI engine is more than SI engine. Why? Because we have already discussed in the previous question that compression ratio in CI engine is way more than SI engine, right? And since the compression ratio is more in CI engine, so there are a lot of pressure inside the cylinder, right? Peak pressure inside the CI engine is more than that in SI engine. And to withstand that pressure, you need to make your cylinder sufficiently strong. Okay, you need to make that cylinder strong, otherwise it will, blast, right? It will be destroyed. So to make the cylinder strong, you need to put more metal, right? Correct. So since there is more metal, so these are heavier. Correct. In SI engine, compression ratio is less, so the engine does not require that much metal. Okay, correct. So this is one aspect. Okay, so in my opinion, that and so in UAV applications, I will prefer SI engine because these are lightweight. Okay, and if I ask which type of engine you will prefer, 4-stroke or 2-stroke, then I will prefer 2-stroke engines because they are again lightweight. Okay, so weight is the main constraint while designing these type of engines for UAV applications. Okay, correct. And you might have seen that grass cutter in your lawn. Okay, so in the older some old grass cutters, they were run using engines, right? Have you seen? बहुत सारा शोर मचाते हैं वो घास काटने वाले होते हैं इंजन से चलने वाले. Have you seen those type of grass cutters? So they are petrol engine or diesel engine. Nowadays they are using electric one, using the motor. But in if you have seen some old lawn mowers, then they are run by engine. So they are also SI engine because you need to hold that in your hand and then you are moving like here and there. Okay, so if it is CI engine, then it will be very heavy and it will be very difficult to operate that. Okay, so in those type of grass cutters also you are using SI engine. Okay, so whenever you require lightweight, then you go for SI engine. Okay, so I hope this is clear, right? On weight basis. So question number 6, it says that the working fluid in an SI engine during combustion is
Air fuel mixture.
air fuel mixture. Okay, and in on auto cycle, what is the working fluid?
Air fuel mixture.
No. Auto cycle, this is an air standard cycle, and in air standard cycle you assume that air is the working fluid. Okay, and you also assume that air is an ideal gas and the properties of ideal gas are constant at all the temperatures. Okay, but in an SI engine the working fluid is air fuel mixture. So auto cycle does not exactly represent this SI engine. Okay, so this is an ideal case. Auto cycle is an ideal cycle. In ideal cycle you are using ideal gas. Okay, just for comparison only, just for making a rough estimate, you are using auto cycle for the analysis of SI engine. Okay, but in real auto cycle, in an ideal cycle, air is the working fluid. Okay, and air is assumed to be ideal gas. But in an SI engine, in an actual SI engine, the working fluid is air fuel mixture. So because of these differences, what differences? That in auto cycle you are using air as working fluid, and in real engine you are using this mixture. So because of these differences, you are getting different efficiencies in ideal case and in actual case. Okay. So what happens in an SI engine? You are getting air fuel mixture inside the cylinder chamber. Okay. So this is your cylinder chamber, and this is the compressed air fuel mixture here. Okay, in the chamber. Then near the TDC, a spark plug will ignite this mixture, and what will happen? There will be development of this flame front. Okay, so this flame front will travel towards unburnt charge region. Okay, this piston will be coming down and this flame will be traveling. Okay, so this flame will come here, then this flame will come here, this flame will come here. Okay, so the working fluid is air fuel mixture and these burnt gases. Okay, so the correct option would have been burnt gases plus air fuel mixture. But since this option is not given, so the most suitable answer in this question should be air fuel mixture, right? But in real case, the working fluid during combustion, it is given during combustion. It is not written that it is before combustion. During combustion means that combustion has already started, right? अगर ये दिया होता, if it was given that before combustion what is the working fluid, then we could have seen it is air fuel mixture, right? But during combustion means combustion has already started, some part of the air fuel mixture has already burnt and some part is still unburnt, so it should be a mixture of burnt gases and the mixture of air fuel mixture. This whole mixture will be your working fluid. But here, since this is not given, then the most suitable answer is this. Okay. And diesel, of course, it is not used in SI engines. Lubricating oil, we don't want to burn lubricating oil. Sometimes what happens, when your piston rings, they are wear out, they have worn out. So some part of lubricating oil can reach inside your cylinder combustion chamber, and that lubricating oil can also burn with these burnt gases. So in those cases, you will see some white smoke coming out from your silencer, right? Have you seen those type of some not very good vehicles, some ये धुआं मारते हैं सफेद सफेद वो. So that is basically because lubricating is oil is also burning. So in those cases you need to change your piston rings. Okay, but anyways, I hope this is clear. Okay, steam is not used in reciprocating engines. So is that clear? So I hope this is clear and we can move to the next question. Which of the following, question number 7, which of the following are the differences between CI engine and SI engine? So spark ignition engine and compression ignition engines. So what are the differences? Ignition method, fuel introduction, number of strokes or thermodynamic cycle?
Ignition method.
Okay, ignition method, of course,
Ignition method.
because in spark plug engines you are using spark plug for ignition, and in compression ignition you are not using spark plug. Diesel is auto ignited, right? Okay, of course, ignition method is correct. Fuel introduction, is it same in both engines or different?
Different.
Yes, it is different. In SI engines you are using carburetor, and carburetor provides a homogeneous mixture of air and fuel, right? While in CI engine you are using injector, right? So fuel introduction is also different in both engines. Number of strokes, is it same or different?
Same.
Yes, it is same. Both engines are 4-stroke engines. Okay, we are not considering 2-stroke engine. 2-stroke engines can also run on your SI engine. Okay, SI engine can also be your 2-stroke engine. Okay, because the older scooters that were run on the older scooters that were running on 2-stroke engine, they were basically SI engines only. Okay, so SI engine can be 2-stroke engine, but here we will consider only 4-stroke engine. So the number of stroke in SI engine as well as in CI engine, it is 4. Okay, so number of strokes is same. So thermodynamic cycle,
Different.
different. For SI engine, okay, I will just list down these things. Okay, here it is SI engine and CI engine. So ignition method in SI engine is spark plug. In CI engine, it is auto ignition. Fuel introduction method in spark plug, it is using carburetor, and in CI engine we are using fuel injector. Number of stroke 4. Thermodynamic cycle in SI engine it is auto cycle. In diesel engine it is diesel cycle. Okay. So A, B, and D. These three options are correct options. Okay. Is there any doubt? So if there is no doubt, then we will move to the next question. Question number 8. It says, in a 4-stroke engine, how many crankshaft revolutions uh, occur per complete cycle? One complete cycle.
Two.
How many? Yes, correct. Why? Because 4-stroke engines. Because for one. Yes. For. Sorry, it is. The pen is not working. Okay. Okay. One revolution of crankshaft, it corresponds to 2 strokes. Okay. So how many revolutions will be required for 4 strokes? 2 revolutions will be required for 4 strokes. Okay. And in 4-stroke engines, 4 strokes complete one thermodynamic cycle. Correct. So one thermodynamic cycle corresponds to 2 revolutions of crankshaft, 4-stroke engines. Okay. Correct. And in 2-stroke engine, how many crankshaft revolutions will be required for one cycle?
One.
One revolution. Okay. So question number 9. In which stroke in a 4-stroke engine involves both valves being closed? So you know there are 2 valves, intake valve and exhaust valve, and there are 4 strokes: intake stroke, compression stroke, power stroke, and exhaust stroke.
Yep.
So in which stroke both the valves are closed?
Compression.
Compression stroke. Because if any one of the valve is opened and you are compressing, then compression will not take place. All the content will come out, right? It will be like exhaust. Okay. So during compression, both strokes are closed. Okay. Sorry, both the valves are closed. So this was easy question. We can move to the question number 10. In a 2-stroke engine, how are the intake and exhaust processes are managed? 2-stroke engine. 4 options. Option A, separate stroke for intake and exhaust. Part B, port uncovered by piston movement. Part C, camshaft control valves. Part D, external pumps.
Camshaft control valves.
Huh?
Camshaft सर कंट्रोल वॉल्व को कंट्रोल करने के लिए काम आती है camshaft जो कनेक्टेड होती है सर रोकर आर्म और उनसे.
Yes, but here we are talking about 2-stroke engines, and we have already discussed that in 2-stroke engines there are not valves. Ports are there, right? Intake port, exhaust port, transfer port. Valves are not there, right? Have you seen that picture that I have shown in another PDF? Is it here? Okay. So here, if you see, only ports are there. You will not see uh, any valves. Can you see any valves in the first picture? Okay, please consider this first picture. Is there any valve? There is no valve. Correct. Because if there are valves, then what will happen? Valve ऐसे अंदर आ जाएगा, फिर ये टकरा जाएगा ना पिस्टन से. Correct.
Yes sir.
So in 2-stroke engines, only ports are there. Valves are not there. Sorry. So camshaft control valves are there in 4-stroke engine. 2-stroke engine valves are not there. Part A says that separate stroke for intake and exhaust. Option
No.
no, because in the same stroke this process takes place, right? Lot of overlap is there. Port uncovered by piston movement. I have already shown you the picture. There are no valves. Ports are covered and uncovered by the piston movement. Okay, correct. So this is the correct option. Port are covered and uncovered by piston to complete all the processes. Here we are talking about intake and exhaust process. So port will be uncovered, right? So from the exhaust port, burnt gases will come out. From intake port, the air fuel mixture come inside the crankshaft. Okay. Part C, camshaft control valves. No, because there are no valves. External pumps. No, no external pump. Okay. So I hope this is clear. 10, question number 10. In two strokes, actually, uh, within two stroke itself, the whole process is completed. Okay. So sometimes it is confusing. Okay. But if you have seen those pictures carefully, then you will not, I think, you must have understood how what is going on, right? If it is clear, then we will move to this question number 11. Again, two-stroke engine. What drives the intake of charge in a two-stroke engine? Part A says camshaft timing, pressure difference created by the piston movement, turbocharger, or fuel injector. It is saying what is causing the intake of charge in a two-stroke engine.
Pressure difference created by piston movement.
Yes, in both type of engine, whether it is four-stroke engine or two-stroke engine, the pressure difference created by the piston movement is the reason behind the intake of charge. In four-stroke engine, when piston is moving towards BDC, vacuum, some not complete vacuum, some sort of vacuum is created inside the cylinder. So the pressure inside the cylinder becomes less than the atmospheric pressure. So the air comes from the atmosphere to the mm, atmosphere to the cylinder chamber. Okay. While in two-stroke engine, what happens? When the piston is moving upward toward TDC. Okay. When the piston is moving upward, okay, when it is moving upward, so it is creating some sort of vacuum here, and air fuel mixture comes from this fuel air mixture. Okay, and when it comes down, then it compresses the content of this crankshaft. Then this content will come inside this cylinder chamber from the crankshaft. Okay, again because of the pressure difference. Okay. Okay, so the correct option is part B. Okay, so I hope this is clear. Question number 12. It says, why do two-stroke engines lack separate intake and exhaust strokes? In two-stroke engines, we have already seen that there is no separate intake and exhaust stroke. Okay, they takes place in the same stroke. So option A says they use valves instead of ports. Part B says the intake and exhaust occur simultaneously during the power and compression strokes. Part C says they operate at lower RPM. Part D says they have fewer moving parts. So let us see all these options one by one. Option A is saying that they have valves instead of ports. So this is of course
No.
not correct. right? We have already seen that there's no valves in the two-stroke engine, only ports are there. So option A is not correct. Part C, they operate at lower RPM, revolutions per minute. No, it has nothing to do with RPM. In fact, the two-stroke engine can run at very high RPM. Okay. Part D says they have fewer moving part. Also, it does not, answer our question. And the second part says that intake and exhaust process occur simultaneously during the power and compression stroke. So part B is the correct option. We have seen this, right? Is there any doubt in this? If you are still have any doubt, then please ask. And I will suggest you to watch some animation for both type of engines. Okay, so there on YouTube you will find very good animations. Okay, how these ports are opening, how these ports are being closed, and in case of four-stroke engine, how these valves are being opened and closed, how all these processes are taking place. Okay, very short videos, just few minutes. Okay, again, I'm sorry. So they're very short videos. Okay, you can watch, and it will, easy for you to understand using those animations. Okay. Is there any doubt, or we can move ahead? Okay. Question number 13. Which component is absent in a two-stroke engine? Crankshaft, camshaft and valve system, piston rings, or spark plug? We have already discussed this many times like in many previous questions. That in a two-stroke engine we are using port, not the valves. Okay, so camshaft and valve is absent in a two-stroke engine. Piston rings are obviously there. Okay, if there are no piston rings, then there can be leakage of your gases inside the crankshaft, and there can be leakage of lubrication oil to the cylinder chamber, combustion chamber. And part D says spark plug. No, spark plug is there, right? Because you want to ignite the air fuel mixture. Okay. And whenever you have any doubt like two-stroke engine, which component is there, which component is not there, then just remember your old-fashioned scooters. Okay, so those scooters, they were running on diesel or petrol. They were running on petrol, and in petrol engines you use a spark plug, right? So I hope this is clear. Okay, if you have taken the old scooter to the petrol pump, then many times you have asked for 2T oil. Have you heard this term, 2T oil? I think you have not heard, because all of you are new people. पुराने वाले स्कूटर मतलब उसके लिए गए नहीं पेट्रोल पंप पे. So it is interesting. Just read what this 2T oil is, how those old scooters were working. Okay. Anyways, so here we comes to the end of our session. So I hope that all the questions that we have discussed, that is clear, and you must have learned something new. And I hope that this session will be helpful for solving your assignment problems. And if there is any doubt, then please ask. This we call as live interactive session. Okay, whenever you might have got the notification via mail. In the mail, it will be written that it is a live interactive session. So please make it live and interact. Okay, then we will be able to justify the name. Okay, so how many people have joined? Aman, Bhaskar, Banti Chaudhary, Charan, Kirtan, Piyush, Ramsundar, Saurabh, Pradeep, Stephen, Tanishq, Yogendra. So thank you all for joining. If there is no doubt, then we will stop here. Okay. Okay. Good night. Take care. We will meet in the next session.
Thank you, sir.
Okay. Thank you.